Hello and welcome to Avanade Energy Series. Today in the studio, I've got Tom Bowcutt, the Global Product Owner for Reactive Technologies. Tom, who are you? Tell us a little bit about your background.
Cheers, Taryn. It's a pleasure to be here. So my name's Tom Bowcutt. I'm currently the product lead for our trade energy product, where we bring insights to short-term power traders about power grids around Europe with our measurement devices.
Amazing. So, given you're a long-time energy enthusiast, and I say enthusiast, but an industry veteran, I should say, who's been in the sector for more than 20 years doing power trading across technology, across consulting, across products, I'd really love to understand first from you, what is the role of the power grid? Or shall we rewind back and say, what was the role of the power grid before renewables started to come on the grid?
Yeah, sure. So traditionally the power grid, it's there to transport power from the generators to the consumers, which may be yourself at your home or an industrial user. Traditionally, we had a small number of generators, large generators, typically running on fossil fuels, gas or coal, or even oil. And we had a very predictable and well understood setup on the grid, all being operated by the grid operators in the UK national grid.
Great, and that was the good old days, and then renewables started to come on the grid, and now we're in an influx of renewables, especially with the decarbonization pledges that have been made, and that just means we're seeing an acceleration in the change of the fuel mix from what it was before. Talk to us a little bit about the impact of that on the grid, Tom.
Yeah, sure. So we've moved from a predictable, well understood, scheduled set of generators to renewable generators, which obviously have some inherent variability. You know, when's the wind going to be blowing? How sunny is it going to be? What's the cloud cover going to be?
And if you're in the GB market, then when the sun's going to be bright and when the wind's going to be blowing is very unpredictable.
It can be unpredictable. The sun doesn't shine that much, but sometimes it does. The other problem that we have is as we have the renewables on the grid, they're also becoming smaller and decentralized. So when we say decentralized, rather than being one or two large units connected to the transmission grid, you're seeing smaller units inside the distribution network. And we also see on the consumer side, so as a customer, you might have solar panels on your house, you might have an electric vehicle that can be charging potentially in the future, discharging into the grid as well. So the fundamental aim of the grid to safely and securely move the electricity around the grid is the same, but the complexity of the challenge and the moving components in that challenge is at a different order of magnitude.
So the grid, which was designed for big generation back in the day, which was very predictable, has now moved into an era of providing that capability for smaller assets, and these smaller assets are more spread out and more smaller in size. So the role of the grid, the power network is transforming as we see it. And when we see that change, what are some of the challenges that come along with it?
Yeah, so one of the challenges that we're quite focused on at Reactive Technologies is managing the level of inertia on the grid.
Ooh, a new term. We love new terms. Talk to us about inertia. What is inertia?
So before we go to inertia, let's just take one small step backwards. So on any power grid, a key role of the grid operator is to maintain the balance between generation and supply. And that's important to maintain a stable grid frequency. So in the UK, we have a target frequency of 50 hertz. If we have too much generation, the frequency will go up. If we have too little generation, it will go down. So a big role of the grid operator and the whole market structure is to try and keep that balance sustained at all times. Now, traditionally, with the large spinning mass that you have in a gas turbine or in a coal generator, you have this thing called inertia. Basically, what that means is that you have a lot of synchronized generation that gives you some momentum or inertia in the grid. So if something breaks, those spinning turbines will kind of keep the grid operating at a stable level for some period of time. Now, as we move away from that traditional generation into renewables that don't provide inertia in the same way, we have that lower level of inertia, and the frequency, if something breaks, can drop off much more quickly. So we have a much higher rate of change of frequency. And what that means is potentially there's a higher likelihood of a kind of runaway issue with the frequency, where as the frequency drops, all the generation slows down, the power drops off, and there's a feedback effect, and eventually you could have a blackout. So the grid operators are having to manage the transition from high inertia grids to lower inertia grids.
Great. So inertia is very much the flow of the current on the transmission network. Would that be a fair way of describing it?
I think you could think about it, and a way of thinking about it would be the resistance of the frequency to changes in generation.
Right.
So if you have a high level of inertia on a traditional grid, you have a kind of stiff frequency that's harder to move. And as you go to a low inertia grid, you have a frequency that can easily deviate from 50 hertz.
Okay, and that would mean you probably need to measure the frequency in near real time. Now I know, Tom, before you invented a new patent technology, it was very much a manual mechanism of taking these frequency readings. So talk to us a little bit about the innovation that Reactive Technologies, without deliberately trying to invent this technology, has brought to the forefront. We'd love to know how the story of Reactive came about.
Yeah, so it wasn't me who invented this methodology.
I thought you'd just take the glory.
Yeah. But as a company, we developed the first methodology for live measuring inertia. And this grew out of a kind of innovation project that we were running with National Grid that initially wasn't focused on measuring inertia at all. It was thinking about how do we implement demand side response, so how do we turn things off if we have an issue on the grid. And the idea was to encode messages and send data through the power grid into the wires that come into every socket that go to every generator site in the grid by encoding messages in the grid frequency. So as a company, the first exercise was using kettles which we were turning on and off at the same time, and we were making an impact on the grid frequency in a controlled way, and we were measuring that at different points on the power grid. And then we started to scale that up. So the idea was to send messages through the grid. So the first message was UK grid OK, which we were pushing into the power grid, and we were measuring it and reading that data out. Now, that was all very interesting, but there were some challenges with that in terms of how well does that message propagate through the grid, and how quickly does it propagate through the grid. And the eureka moment was when someone realized that it was kind of inversely related to the level of inertia on the grid. So when you have a high level of inertia on the grid, the signals were not propagating as well. And when you have the lower level, they were propagating more easily. And so from that, you can kind of derive in real time what your inertia level is on the grid.
That's amazing. So the concept of passing the signals and reading them was the first step in the journey, and when it took longer than expected, you were easily able to decipher that there's something that's causing the slowdown, which would mean that there's potentially a problem with frequencies. That's great. And so how many devices do you have on the network already?
Yeah, so on the UK grid, we have somewhere between 40 or 50 measurement devices. So the solution is two parts. It has the measurement of the frequency, and it has the modulation. On the UK grid, we have one ultra capacitor. It's a 5 megawatt ultra capacitor. We use the ultra capacitor to push the signal into the grid, and then we have 50 sensitive measurement devices. We're moving into different grids as well. So we have measurement devices and modulation over in Australia, live in Taiwan. We have some devices across Europe, and also we're putting some into the US now as well.
Impressive. So how many readings are you getting out of one device, and how big is the set of data that you're dealing with in real time?
Yeah, so in a basic mode, we would read from a device 50 readings a second, but that can be moved up to kind of ultra high definition, where we could get up to 48,000 readings a second, which is, we're not doing that all the time, but that's kind of the ultimate capacity that we could run the devices in.
So is the secret sauce of the business in where these devices are located, or is that public knowledge?
The secret sauce is probably more in the measurement device methodology and the processing of the data. The location of the modulator in UK is quite well known. It's up in Teesside. You can see that on the internet. You can see some nice photos of all the management team at the site, it looks like a battery container, to be honest. And then the measurement devices are just strategically placed around the grid. There's no IP in the location of the devices.
So I could have one in my office then?
Yeah, I've got one in my office. They just plug into the plug socket and they plug in and play. They connect themselves up to the platform and you can start to see the frequency by your house. We have a few nice ones. I'm in Brighton, so I've seen a few interesting days where we've had a few trips in Shoreham Power Station, and also some of the interconnectors into France are quite visible from there.
Brilliant. So what is the product and who's the consumer of this product?
Yeah, sure. So kind of the primary market for the inertia measurement will be the grid operators. So you're talking about people like National Grid or AMO over in Australia. So that is the inertia measurement service that we provide, and we also do something called oscillation detection product for those customers. We're working more and more as well with distribution grid operators. So similar to how you have the inertia problem at the transmission grid level, looking at the equivalent in voltage that we call system strength in the distribution grid. And then me, myself, I'm working with short-term power traders. So that's where the trade energy product comes in, and we're looking at detecting and locating generator and interconnector trips in the grid. And we're also starting to work with asset developers. So there are people building certain types of assets that add inertia to the grid, and we're helping to support those customers with where do they put their assets, how do they show that their assets are adding the inertia levels to the grid that they've been contracted to provide.
It's so critical to get the location of these assets right, because when the grid is constrained and frequency disruptions happen, then bringing those assets on would be tremendously valuable if they were placed at the right location.
Yeah, so the element there that you're looking at is probably pre-disruption is where do you put the assets in the grid that will help the overall stability of the grid by adding inertia to the weak points, if that makes sense.
Great. Well, trade energy product, very interesting. But Tom, are we duplicating efforts there? Doesn't remit and now refit provide a mandate to generators to publish unplanned outages to the market before they go and trade them?
There is. So for people who don't know what remit is, so there's a part of remit is if you have some inside information, i.e. you know that your power station is broken, you have to make that available to the market before you start to trade from that information. That's there for good reasons, because some people were doing some naughty things that you can watch on YouTube about manipulating the market by pre-arranging outages of their assets. But that information does have some element of delay in it. So in a typical process, something would break at the power station, some information would go to the trade floor would have visibility of it, then they might publish that into the market. So there's an inherent delay in that process. What we're doing with trade energy is we see that impact on the power grid, on the frequency of the power grid, and we detect that and we provide some processing on that and surface it ahead of those notices going out through remit.
So in essence, that could be a faster way of making the detection than what ultimately the remit message notification would be. Great. So is the product trade energy applicable for physical traders, or is it more for financial traders? Talk to us a little bit about that.
Yeah, so I think both. So when we talk about financial traders, I would say non-physical traders, so someone who doesn't have a physical consumption or physical delivery of electricity, but they can do an element of speculation on the price. So they might buy it, they want to buy it at a low price and sell later at a high price, something like that. So that would fit quite well with the event detection. So effectively you see an event on the grid, you're alerted about it, you buy some power, the rest of the market finds out and the price goes up and you sell that later. So that would be a kind of non-physical strategy. If you're a physical trader, normally means that you have some kind of asset that you can either produce or consume electricity from. And then that would work in a similar way. So if there has been a trip of a large generator, or you've just lost a large interconnector import into the UK, you can expect that that's going to impact the market prices. It will also impact the system prices and the imbalance prices. So you could use the event detection as a signal to maneuver your asset to capture, for example, imbalance prices. And so it can be an input into some processes like NIV chasing, which is a way of forecasting where imbalance markets are going to go.
All right. So in that equation, Tom, given your years of experience in power trading markets, I'd love to hear a little bit about how the power trading markets work from a long term to a short term to an intraday, and how is generally power trading in the long term to a short term horizon?
Yeah, great. So nice question. So when we talk about power trading, we often split it up into long-term and short-term power markets. When we talk about long-term markets, we're talking about trading larger chunks of power at a lower resolution, but far out. So it may be in 2 years' time, I have a bunch of customers and I know they're going to use a lot of electricity during the day, not so much during the night. So I could be buying and selling contracts for summer 2026, off-peak and peak. So at that point, I'm kind of building my base profile of my expected customer use. And then as we move closer to delivery, we start to trade in a higher level of granularity. So as we go into the day-ahead market, I might be trading hourly blocks now. Have a better understanding of when I think my customers might be using electricity. I have a more recent demand forecast. I have a better knowledge of the weather for tomorrow. And then after that, we come into the intraday markets. And in the UK, you can trade half-hourly blocks. In Europe, some places it's 15 minutes. But it's all about refining and getting a more granular view of what's going to happen and trading that shape. But then at a certain point, typically, the market will shift from, say, me and you buying and selling power to having the grid operator taking more control. And the reason that they do that is that they need to maintain this balance between supply and generation to keep the frequency at the right level and make sure the lights stay on. So then typically in that kind of short-term window from, say, half an hour and an hour before delivery, the grid operator will be making trades directly in the market to keep the balance as it needs to be. In the UK, they do that through the balancing mechanism. And then at the end of that process, we have got different names in every market, but it's generally imbalance settlement. But what we're looking at there is that cost of balancing that the grid operator does needs to be recovered from the people who have imbalance positions. So if I've generated much less than I said I was going to generate, I need to cover that by paying some money into this imbalance pot. Or if I've generated more, I may get paid some money from that imbalance pot.
Right. So it's fair to say that the sophistication of the technology, the infrastructure, the platforms are really important for success of long-term and short-term power trading. When you go from the long-term horizons to the short-term horizons, the accuracy of the data is really critical. The speed of processing of that data is really critical. And I know traders love spreadsheets, but sometimes I think in the era we are, spreadsheets may not be the right answer. So what is your perspective on sort of the system landscape around the evolution of the volumes of trading that we're seeing with the influx of renewables coming on?
Yeah, I mean, the renewables, I think, have naturally pushed much more focus on the short-term markets. So traditionally, a lot of the money moved around in the long-term markets, and it was refinement in the short term. But now more and more people are holding back their decision-making into the short term, and it makes sense because you're looking at renewables which are much more influenced by weather, so therefore you have more uncertainty and you have more volatility inherent in the short-term markets. And of course, if you're looking in the short-term markets, the turnaround and speed of processing has to be much higher. And as we were talking about moving away from these kind of centralized predictable assets into this fragmented, decentralized set of generation, there's just another order of magnitude to data involved. So your whole sophistication of your data processing needs to be at a different level.
Brilliant. So, Tom, you've worked with the National Grid, which is our GB market, and you said you're working in Taiwan, in Australia, in America. Talk to us in comparison of what do the other markets look like, and then contrast that back to tell us what do you see the maturity of the GB market be?
Yeah, so I think for us at Reactive Technologies, because we are focused on inertia, there is an element of market maturity. So the inertia challenge is more visible on island grids. And the reason for that is that you have inherently less inertia in a smaller grid. So on an island grid, you will see the need to measure inertia earlier than you will on, say, the mainland EU grid. And we have, in the UK, we have a reasonably forward-looking grid operator, National Grid, who's kind of push that forward. So we have stability pathfinders where a market is being created for providing inertia, and we have reactive technology measuring inertia. But more and more grids around the world will see that inertia problem. So the larger grids are starting to see that. So in Australia, where we've been working, they have some challenges there just because the country is so big and the impact on the grid is quite high. And then as we start to get more and more renewables on, we'll start to see that in larger grids. So in the US, they're starting to look at that now through a lot of innovation projects that we're involved in. And we'll start to see that coming into the European grid as well, more and more.
There is a trade signal when you detect that there's an outage that's happened. And if you can get that signal early from the rest of the market, then you have almost an advantage of being able to get early movers advantage within the market. Now, it's all easier said than done. Have you done any studies to see when historically outages have happened, what has the upside been for customers that have gotten that trade signal a bit earlier than the market?
Yeah, sure. So that would be quite a normal process for any trader who wants to run a new trading strategy. They would go through a process of back testing. We can do that with our data. So we just look at our events data. We say what happened, when do we get the event message out, and how did the market move? So how did the market prices change? And we can build what I would call anyone would call a shadow strategy. So effectively a very simple shadow strategy would be to say, let's assume we bought some power at the time we got the event notice and we sold it 5 minutes later. How much has the price moved? So we've done that process with an external party, Brady, and we have a paper published on that. And then for customers who are looking at the product, we provide a data set that they can do that process themselves.
And so I hear lots the word VWAP being used in the measurement of the upside that's been able to be obtained. Could you talk a little bit about that measurement and how that plays into the study that you've done?
Yeah, so VWAP is volume weighted average price, and it's used in all traded markets. If you can imagine that there's trades happening all the time at different prices and different volumes being traded, how do you build a benchmark of the average price that could be achieved? Is just the volume weighted averages of all those trades that have happened. And you can kind of think of that as, on average, if I was trading and I did that, I'd be like the mediocre average trader. If I achieve a better price, then I'm a good trader. And if I below that, I'm less good.
Okay. It's quite a metric then, isn't it?
Yeah, so it's a key metric, really. It's nothing particularly related to trade energy. It's a standard way for the traders to kind of benchmark their performance against the rest of the market.
Okay, so I'm going to put you on spot here. What kind of upside have you seen for customers that have the early advantage of the signal versus the rest of the market?
Yeah, so I mean, on the big trips on a generator or interconnector can move the market by maybe 20% the market price. The crux of it is the speed of delivery of that. So despite the fact that we talk about remit, there is data out there and people do see these things and act on them very quickly. And what we've been doing on our roadmap is kind of bringing that speed down and down and down. And the aim is to get it out as fast as possible.
So how long do you usually take in today's world to process that signal?
Yeah, so when we first released the product, we were doing the full analysis. It took about 2 minutes for that to come out, which was still well ahead of the remit notices. Last November, we got that down to below 20 seconds. And by the time this podcast goes out in August this year, we will be sub 5 seconds.
Wow. I mean, when I look at some of the market published messages around remit, they are way, way, way longer than that. So there's an unsaid advantage here, right? For your consumers of the product, being notified in that short speed means they've got full access to the market. And if their peer group doesn't have this product, well...
Yeah, I think I'd expect that the first people will see some kind of first mover advantage, and then hopefully it will become a kind of standard methodology. Some people would call it the remit killer, but we'll see. Hopefully it'll become something that's helpful for everyone.
Great. So it is a big data problem you're solving, aren't you here? You've got different measurements coming from different locations in real time, different grids altogether, separation of data sets across your product for national grid, across the product for your trade energy consumers. And apart from that, I guess you're running algorithms, doing some machine learning and AI on top of it to validate the false negatives, and then a streaming platform of sorts to alert your customers as well. So we'd love to know a little bit about the sort of platform engineering and the innovation that goes with it.
Sure, yeah. So in terms of the kind of data scales, so in terms of modulation to the grid, we're doing that about 22,000 times a day. And then in terms of measuring the frequency on the UK grid, it's about 200 frequency readings a day, 200 million frequency readings a day. So it's a large pot of data. But again, that's one small slice of the picture, right? So we're bringing that picture for inertia measurement for the grid operators and for event detection for the traders. But that is a huge data volume just for that kind of one niche element. And then if you think you've got all the weather data, weather forecast, demand forecast, metering from all the EVs and every other form of generation on the grid, the whole thing is just at this different scale to what it was, when I started 20 years ago and we were moving data around in XML files and all that kind of thing.
Yeah, I remember that era. It was fun, but this is thrilling. And so not only is that the data for the real-time analytics, but the historic analytics as well, right? Because you want to be, to some extent, predicting these situations by looking at the historic conditions, which isn't just a time series, but a culmination of many.
Yeah, of course. I mean, we're training the models off the back of the historic data. I think one of our visions as a company is that we will have this visibility and this track record of this granular data for the majority of power grids around the world. It becomes useful for things that you don't necessarily know that you're going to use it for. So that came in last year when National Grid was seeing some issues with oscillations on the grid, which meant they were constraining and stopping some generation from running. And we were able to see where the source of that problem was coming from in our data. Now, we didn't save the data and have that in mind when we started to store it, but you have to keep that, and you have to keep that full data history, and you need the tools to access that as well.
Brilliant. So you're helping the grid stay balanced. You're helping the grid be more clean and bring on more renewable. You're helping the grid reduce its carbon. At the same time, you're helping reduce the implications of the end consumer's invoice, essentially by netting off the balance prices. So you're doing a lot. How old is the company, and where is the product evolving from here?
Yeah, so the company was formed in 2010, so we've been around for a while, and that's been a series of startups and iterations towards what we are now, which is a power grid monitoring company. We did some PPA management, we did some demand side response type things. And I think in the future, the aim is to become the global grid monitoring company. So that idea, and we're on a good journey on that so far, is having devices across the majority of power grids around the world, and providing that information and that visibility and that transparency to a range of different customers.
Good. So what are all the grids you're working with today?
We're in quite a lot. So in Europe, we're in 14 different countries. We have monitoring devices now. We've got some projects in the Middle East. We've got some projects, I've mentioned Australia and Taiwan before. We've got projects in Australia. So we're getting there.
So are you getting on a plane every time you unlock a new country and a location?
No, I'm not. We do have a few people traveling on planes, but we have the exact company set up is we're about somewhere between 60 and 70 people now. Half of those in the UK, half in Finland, which is a lot of the technology came out of the mobile industry. So there's a lot of the research and development sits there. And then we have hub offices around the world. So we have a hub office down in Australia. There's a hub office in Australia, in US, and there's a hub office in the Middle East. And those will grow with the company.
Brilliant. Tom, I'm really enjoying this chat. And given your experience in the power trading markets, I have to ask you, what are your top 3 predictions for the power trading markets, but also the technologies that go with them?
Yeah, so I don't even know if I'd say the first one is a prediction or it's just where things are, and I think it will carry on. The importance of weather data. It's always been important in power markets. It's becoming more and more important to understand not only your forecast, but to what extent is the actual delivery deviating from the forecast. And I think people who can have that visibility and do sophisticated things in the big hype area at the moment, which is AI, and bring that kind of knowledge into weather with the power market context will do very well. That will probably link to the second area, which is kind of just more and more connected devices. So more and more live measurements from, traditionally people have had SCADA systems and they can get that from the big generators and the big renewable farms, but just having more and more visibility from connected devices, bringing all that data in and also turning that around and drawing some insight from it very, very quickly. And then the third area, I guess the way I see things going possibly is more and more interest in power markets from some of the big tech companies. So if you look at the big tech companies with these large data centers, they have a large consumption base. They're working more and more to try and ensure that that's being provided from green generation. And then you look at the kind of data that they have and the skills that they have in those areas as they get more and more interested in power markets, and you can kind of see, them coming more and more into that space. Whether they'll go into residential supply kind of depends. It's a tough area to make money at the moment.
Prediction,
yeah.
Right? So we won't hold you to it. We will. Great. So Tom, where do you then see some of the technology innovations emerge? You sort of tied in the technology innovations very much to the business trends as you see them. But if you had to make one big technology predictions across all of these trends, what would that be?
I mean, for me, I've always been very interested in the connected devices. And I think as we have more and more devices connected, and you start to look at electric vehicles and things coming on, this kind of idea of like a smart grid that can kind of self-optimize and self-maintain its balance with kind of less and less manual input and more like direct communication between the grid and the devices is kind of the vision that a lot of people have had for a while, and we're kind of getting in that direction.
Yeah, so it's fair to say, in summary, that the transition to the decarbonization very much has a large data and analytics angle to it, right? And as that accelerated transition happens, we see the need for data, the processing of data, the analytics from it, the predictability from it, the scale from it growing and becoming more and more needed, the accuracy, the timeliness, it all just ties so well together.
Yeah. I mean, everything is leading us to the path to more and more data, and it's just becoming more and more difficult for anyone to like hold that in their heads in the like time frame to react. So the automation and all the systems around that and the processes, they need to be more and more robust, but they also will become more interesting for people like yourself working in technology, I think.
We love data and analytics at Avanade here, Tom. Let me tell you that.
Do you?
So Tom, I want to give you an opportunity to plug something.
So I think the big interesting thing for me on the trade energy side at the moment is we've been putting our devices into Europe, and we'll be looking later this year to have an offering in the German market. I think that's quite interesting in terms of how the transparency of that market works. And then we're also looking to work more and more with people building assets that add stability to the grid. So people who are building batteries with grid-forming inverters, we're looking at how we can provide some support to them to kind of demonstrate how they're providing more inertia to the grid. So those are the two things, and if anyone's interested in those, please reach out. Happy to discuss.
Amazing. I'd encourage all our viewers to link up with you on LinkedIn and follow all the insights that you share. And if they're interested in trialing out the product, then touch base with you as well. And it's been a pleasure talking to you, Tom, on the Avanade Energy series. And thank you for sharing all the insights. And we look forward to having you back in the studio when you've expanded more globally into the market and have more insights to come back and talk about.
It's been a pleasure. Thanks, Taryn, and look forward to doing it again.